Hello everybody, welcome back to my YouTube channel. I am Amrita and I'm back here with a new topic that is mesh analysis on the subject network analysis. And I request you all to please stay along with me till the end. So without wasting much time, let's get started. Mesh analysis in network analysis. Introduction to mesh analysis. Mesh analysis is a circuit analysis technique used to determine the current in a circuit. It involves applying Kirchhoff voltage law, that is KVL, around closed loops in the circuit. Mesh analysis is particularly useful for planar circuits with multiple loops and components. So here is just a diagram of a circuit where you can see two meshes, that is mesh 1 and mesh 2, and in mesh 1 you can see the current I1 and the current I2 in the mesh 2. Basic concepts of mesh analysis. A mesh is defined as a loop that does not enclose any other loops. In mesh analysis, each mesh is assigned a mesh current, which is the hypothetical current flowing in that loop. The mesh currents are used to create equations based on KVL, leading to a system of linear equations. So basically now we here in this diagram you can see there are two mesh. Now for this mesh you can see the mesh 1 has a current I1 and current I2 for the mesh 2. Now for these two meshes we are going to apply KVL separately, and whatever the equations that we are going to get, we are going to solve them. Steps in mesh analysis. Identify all the meshes in the circuit and label each with the mesh current. Apply KVL to each mesh and write down the corresponding equations. Solve the system of equations obtained to find the mesh currents. Kirchhoff voltage law, that is KVL. KVL states that the sum of all voltages around a closed loop is equal to 0. This law is fundamental in deriving the equations for mesh analysis. Each voltage drop across a resistor is calculated by Ohm's law, that is V is equal to IR. So for this example you can see there is a current that is 1.8 ampere and this is a single mesh. So now we are going to apply KVL and everything. So here V is equal to IR, and now we are going to find R1, that is equal to 2 ohms, and R2 again apply Ohm's law and you're going to get it as 3 ohms. Example of mesh analysis. Consider a simple circuit with two meshes and three resistors. Assign mesh currents, that is I1, I2, to each loop and apply KVL. Solve the resulting equations to find the values of I1 and I2. Advantages of mesh analysis. Mesh analysis simplifies the process of solving circuits with multiple loops. It reduces the number of equations needed compared to using node analysis. This method is efficient for circuits that can be easily drawn in a planar format. Limitations of mesh analysis. Mesh analysis is only applicable to planar circuits which cannot have any overlapping loops. It can become complex with the presence of dependent sources and nonlinear elements. For circuits with many nodes and meshes, the size of the equations can grow rapidly. Mesh analysis with dependent sources. Dependent sources can complicate mesh analysis as their values depend on other circuit parameters. The mesh equations must account for these dependencies, usually by incorporating additional variables. Careful attention is required to ensure all relationships are correctly represented in the equations. Comparison with node analysis. Mesh analysis focuses on loops, while node analysis centers on junctions in the circuit. Both methods can be used interchangeably, but one may be more convenient depending on the circuit configuration. Understanding both techniques enhances overall circuit analysis skills. Thank you. I hope you all enjoyed the video, and I request you all to please hit on the like button and share it with all your friends. Until next time, take care.